Hey everyone, welcome back to my channel. In this tutorial, I'm going to show you how to run a one-way chi-squared goodness-of-fit test in Stata. So that would be testing for equal proportions of the categories in a categorical variable with multiple categories. So I'm going to work on a variable called S group. So let's tabulate it and execute the selection, and let's see this variable distribution. So as you can see, there are 6 groups, 20 to 29, and their frequencies. So under these 8 groups, there are 2,320 respondents or research participants. And here is the relative frequencies here. As you can see, this varies across the age group. So we can see that for 60 to 69, so that would be 27.63 percent. So these people, maybe they're the baby boomers, so are the greater in number, right? 2,860 people. However, you just see the 70 plus people, they're only 986. However, so we can kind of gaze and see from our observations that they don't seem to be equal, but we need a formal test to confirm that these age group distributions are not uniform, right? So let's say that you conducted a survey, and from your census data, level data, you know that the age groups are equally distributed, meaning that each age group has similar frequencies or compared to other age groups, right? So there are 6 age groups, and we can see that there are total 10,351 observations. And so if you divide 10,351 by 6, meaning 6 groups, that would be 1,725 observations for each of the age groups, right? So that would be our expectations if we know that the age groups are equally distributed, um, and they're like uniform across the groups, right? So so we are going to formally test if the distribution of these S groups are uniform. So let's go back to my do file, and we're going to manually put the observed frequencies here. So you from the tab, we got these observed frequencies, meaning that this is the observed, this is what we observed in our sample. So that's why we'll manually put it here. Okay, so you write clear and input, then string 6, so this is the type of storage type, and then the name of the variable, and say observed, and then we put all these age groups and then their frequencies. Okay, so select this and execute the selection. So what we have done is we put manually these frequencies and the age groups for storing. So Stata stored it for us, and then we go back and to the second step, which is total sample size. And you know this total sample size from the tab command we generated earlier here. So 10,351 total observations, and execute the selection. So that's where we stored this data for this analytical purpose as well. So total observation, we let Stata know that that's the total observation. And now step 3, you number of categories, which is 6, and so this is the expected this is the expected frequencies. Okay, so generate expected equals total by 6. So total is 10,351 by 6, so that would be 1,725. So that would be the expected frequencies for all age groups, because we are assuming that they are equal, and we are testing whether they are equal or not. And then select it and execute the selection, and we have stored this data for our analysis purpose. And then step 4, you calculate chi-square statistic. Okay, generate chi term, so you can give whatever name you want, and then this is the formula of the chi-square. So you this is the observed frequency. So for example, for age group 20 to 29, observed frequency is 2320, right? Minus expected frequency. Expected frequency means that we want it to be 1725, like equal. If you divide this by 6, you get 1725, and then bracket and square it, and then divided by expected, which is again 1725, right? So that's how we calculate our chi-square statistic. And let's do it. And we store this data as well. And then at step 5, sum all terms for chi-square statistics. So this is for all of them. So we sum it and we create this summarized chi term. So that's what we generated previously. And then scalar chi square stat, we're creating chi square stat equals r and sum in bracket. Execute the selection, and now we can see chi term as a total. This is the mean, minimum, maximum, standard deviation, and numbers of observations. And finally, we create p-value for our chi-square statistic. Okay, and the p-value, as you can see, so this is the chi-square statistics as a whole, and this is the p-value. So this means it is effectively 0. Okay, so that means we our chi statistics fall below. So this is the probability or p-value is less than 0.05. That means we reject the null hypothesis that they are equal, right, and accept the alternative one, which is that they are not equal. So the age group distribution are not uniform, right? So the frequencies are not uniform across the 6 age groups. That's what we conclude through this test. Okay, so if you so that this is how you determine that the distribution of age groups are not equal, but you never know that what is the population parameter, right? So if you really need to know the population parameter for age group distribution, maybe they are not equal in the population parameter, so then you do not expect equal distribution in your sample as well, right? So that's why you really need to understand your population characteristics first, using the census data, which captures the population level parameters. And without that information, actually, you cannot make any meaningful statistics out of this chi-square goodness-of-fit test. So thanks for watching. I hope this was helpful, and if you find my tutorials helpful, please subscribe my channel, like, comment, and share. I'll share this do file and also the data file that I have used for this video demonstration. Thanks for watching again.